Hi students, good morning to all of you. Today we are going to discuss about dipole moment part 4. In this series we are going to discuss about how to find dipole moment of alkenes, alkynes, benzene, ortho, meta, para directing aromatic compounds and then alkyl halides and carbonyl compounds. Right, let's start. First of all, in alkenes, alkenes exhibit geometrical isomerism, that is cis and trans isomers. In case of cis isomer, two atoms or groups are present on the same side of double bonded carbons. In case of trans isomer, the two atoms or groups are present on the opposite side of the double bonded carbons. Right. Now let's start here dipole moment in cis and trans form, how it is there. So for example, here carbon-carbon double bond, and here methyl group is there, and here methyl group, and downward hydrogen atoms are there, right? So two similar atoms are present on the same side of the double bonded carbon. It is a cis butene 2, right? Now double bond is there in the second carbon. In this compound here, double bonded carbon is sp2. It is a more electronegative carbon. This alkyl group, that is the carbon undergoes sp3, it is less electronegative carbon. That's why the dipole moment, bond moment from double bonded sp2 carbon toward the sp3 carbon, right? And here also from double bonded sp2 carbon toward the sp3 carbon. So both are operated in the same direction. Okay, both the dipoles B1 and B2 both are operated in the same direction. Both dipoles in same direction. Both are in the same direction. So both are added together. So that's why the dipole moment, net dipole moment is not equal to 0. It has some dipole moment value, right? And whose isomer, that is a trans form. Here hydrogen atom on the opposite side, and methyl group and methyl groups are in the opposite direction, right? Opposite side. Now this is a trans butene 2, right? So in this trans butene 2, the dipole moment from double bonded carbon towards the alkyl group, and here also double bonded carbon sp2 to alkyl group sp3 carbon. So both are this is in the upward and this is in the downward direction. Both are in opposite direction. Both the dipoles have same magnitude but moves in opposite direction, operate in the opposite direction. So that's why both are cancelled with each other. So that's why the net dipole moment is 0, right? Got it? Yeah. That means in case of a trans isomer having 0 dipole moment and cis isomer have some dipole moment value. But students, it is always trans isomers of alkenes having 0 dipole moment is not exactly correct. In some books or some masters also they say trans form dipole moment is 0. That is not correct. In some of the alkenes, the trans form have dipole moment value and the cis form have 0 dipole moment. Let us see one example. Take here a double bonded alkene, here methyl group, and here chlorine atom, and here both similar hydrogens are there now. And whose isomer is, you have to represent like this. Here methyl group, opposite side chlorine, and hydrogen is also opposite side, right, of the double bonded carbon. Now here in this case, the dipole moment from sp3 carbon towards the sp2 carbon, and here compared to carbon, chlorine is more electronegative, right? So that's why the dipole moment towards the from sp2 double bonded carbon towards chlorine atom. So in this case, it is the upward direction and this is the downward direction. Both are in opposite direction. So that's why the net dipole moment is 0 here, right? But here it is from sp to carbon, it is sp3. So from sp3 to this carbon, and double bonded carbon to chlorine atom. So both are in the same direction. This is also, this is also, both are in the same direction. So that's why the net dipole moment is v1 plus v2. I have to add up together. So that's why we have some dipole moment value is not equal to 0. Right. That means a transform have a trans isomer have some dipole moment, but the cis isomer have zero dipole moment. Right. Is it clear? Right. Next one. This is an alkenes. Next, alkynes one. So in case of alkynes, carbon-carbon triple bond, here hydrogen atom, or maybe carbon-carbon triple bond, or here methyl group is there, right? Now the carbon is triple bonded carbon is sp carbon, right? You know, sp carbon is more electronegative carbon because this is sp carbon. As percentage of s orbital content increases, electron negativity of carbon increases. So that's why it is more electronegative carbon. So that here the dipole moment is from hydrogen towards the sp carbon. Here also from hydrogen towards sp carbon. Both have same magnitude but cancel each other. So that's why net dipole moment is 0. And here also this is sp carbon, and this alkyne group is sp3 carbon. Sp carbon is more electronegative, so that's why the dipole moment from sp3 carbon towards sp carbon, and from here also sp3 carbon towards the triple bonded carbon. Both are in opposite direction, same magnitude but opposite direction. Both are cancelled each other. That's why the net dipole moment is 0. Right. So this is about in alkynes. Next now we can move to benzene, right? So in case of benzene molecule, it is a symmetrical molecule, right? In case of alkynes also, these are symmetrical molecules. These have linear geometry, right? Linear geometry shape. If you cut the molecule through this triple bond, you will get two equal halves. So carbon methyl group. Here also, if you cut this molecule through the triple bond, you will get two equal halves. That is a symmetrical molecule, right? Students have to keep in our mind, keep in our mind, if in case of symmetrical molecules, the dipole moment is 0 because both are cancelled each other. Okay, just keep in our mind, that is in case of symmetrical molecules, the dipole moment is 0, right? This have to keep in our mind. Now here in case of benzene, it is a symmetrical molecule, right? All carbons are sp2 carbon, and if you cut this molecule through this plane, you are getting two equal halves. Or if you cut this molecule through this plane also, you will get two equal halves. Or if you cut it through this plane also, okay, you will get two equal halves. So that's why it is a symmetrical molecule. So in case of symmetrical molecules, the dipole moment is 0. So that's why the dipole moment on benzene molecule is 0, right? Yeah. Next one, ortho, meta, para directing groups containing aromatic compounds. So for example, here, take it here, this is 3, it is 4, this is 5. Next, 6th example, take it here, a benzene and 2 chlorines are there, 1, 2 position, that is ortho. Next, 1, 3 position, that is meta, and 1, 4 position, that is para, right? So this is 1, 2 ortho, 1, 3 meta, 1, 4 para, right? Now in this case, it is a ortho dichlorobenzene, meta dichlorobenzene, para dichlorobenzene. Which one have highest dipole moment? Yeah. So in this case here, in the case of para one, the moment, this is from carbon to chlorine atom, and here from carbon to chlorine atom. So both have same magnitude but operate in the opposite direction. Both are cancelled each other. That's why the net dipole moment of para isomer is 0. And what about ortho one? Here it is toward this chlorine, from carbon to chlorine. Okay. So the bond angle here approximately will get 60 degrees. You know, one concept, the dipole moment is inversely proportional to bond angle. If bond angle is less, dipole moment is more. This one also keep in our mind, my dear students. Keep in our mind. Okay, this will help you to answer objective questions, right? And in this case, the dipole moment is from carbon towards the chlorine, and here sp2 carbon towards the chlorine, because chlorine is more electronegative, right? So here the bond angle is approximately 120 degrees. If bond angle is more, dipole moment is less. So that's why here these two are in the same direction. So less bond angle. So that's why ortho one have more dipole moment. Next meta, next para, right? This is the order, keep in our mind. Whereas ortho dichlorobenzene is more dipole moment. Next meta dichlorobenzene. Next para dichlorobenzene whose dipole moment is 0. Para 1, right? One more example we can do it here. So take it here. In the place of chlorine here, you may take nitro group also. Here NO2, NO2. So ortho dinitrobenzene, meta dinitrobenzene, para dinitrobenzene. The same thing will get. Okay. You just in the place of this one, if you replace here NO2 group also. Okay. Then you will get the same order. So ortho form have maximum dipole moment, and para form is 0 dipole moment. Got it? Fine. Next, another example. So here the benzene ring, here carbon, and it is having a carbon triple bonded nitrogen, and here cyanide, there is cyanide group. Okay. So you know here nitrogen is more electronegative, so that's why from this toward this dipole moment, and from here double bonded aromatic carbon towards the nitrogen, right? So one dipole moment is to the upward direction, other one is downward direction. So both have same magnitude but opposite direction, both are cancelled with each other. So that's why the dipole moment of this is 0, right? Okay, fine. Next one, another example. We take it here. A carbon, a triple bond compound, will take it here. So here a carbon atom, and it is bonded with a triple bonded carbon and hydrogen, right? CH bond, CH. And here also carbon, triple bonded carbon, hydrogen. This is just represented here. This is a triple bonded carbon, CH, right? Okay. Now here, so this is a sp2 carbon, and this is a sp carbon, you know. This is a sp carbon atom, right? This is sp carbon. Sp carbon is more electronegative carbon, so that's why the dipole moment toward this sp2 to sp carbon, here also toward the sp to sp carbon. So both have same magnitude but opposite direction operated, so that's why both the dipoles are cancelled with each other. So that's why the molecule have net dipole moment is 0, right? Okay, fine. Next one, another molecule. Here the molecule having this OH group is there, right? Here this both are para, but here from hydrogens toward the oxygen atom, and here from hydrogen toward the oxygen atom. So both are in the same direction, right? So both are operating in the same direction. Both are moving in the same direction. So that's why the net dipole moment is added together. So that's why this molecule has 0. Dipole moment is not equal to 0, right? This molecule, okay. So this molecule have not equal to 0, okay. So both is, so this is in this direction, and this is in this direction. Both are in the same direction, right? So that's why, so both are in the same direction. I just represent this one. Both are in the same direction. So both the dipoles are operating in the same direction. So that's why the net dipole moment is not equal to 0. Okay. So that's why always we don't consider the para position is there, dipole moment is 0. That is not correct. Here it is okay. Here it is okay, but it is not correct. Okay. So that's why here some dipole moment value is there. Got it, my dear students? Okay, fine. Right. Okay. So I think you got all the concepts. So please like it, subscribe it, and share to your friends. Thanks for watching my video. Okay, ma'am.